The last section of our analytical geometry is first degree inequality in two variables. You should have already been familiar with the word inequality before. In this PowerPoint, we're going to talk about one variable first degree equations and inequality, two variable first degree equations and inequalities, and how to graph two variable first degree inequalities. First of all, let's review. What is a variable? A variable you should know as x or y because it is an unknown found in an algebraic equation or expression. Usually we use x or y. It's most common now, although sometimes we'll see unknowns as any letter of the alphabet. What's a first degree equation? The degree of an equation is the value of the highest exponent found in that equation. So for example, in the equation 6x cubed plus x plus 3x squared minus 7x plus 9 equals to 56, it's a third degree equation because the highest exponent in this equation is a 3. A first degree equation is when the highest exponent is only a 1. So x plus 3 equals to 10 is a first degree equation because there's an imaginary 1 here over the x. We are going to look at first degree equations in this PowerPoint. Here's an example. A salesman receives a base salary of $150 and receives $20 per appliance sold. How many appliances must he sell to get a salary of $410? I want you to answer a few questions before I give you the answer. First, how many variables are in this situation? Second, what is the equation for this situation? Third, what degree is this equation? And finally, just answer the question. In this situation, there are two variables, x and y, and in this case, we'll call x the number of appliances sold and y the total salary that a salesman will receive. For number 2, the equation for the situation is 20x plus 150 is equal to y, where it's 20 times the number of appliances sold. So he gets $20 per appliance sold plus his $150 base, which gives him a total salary y. This equation is first degree because the highest exponent in this equation is a 1. It's an imaginary 1 at the top of an x or y. And if we were to answer this question, how many appliances must he sell to get a salary of $410? You make this equation equal to 410, and if you simplify and solve for x, you will get 13 appliances. So this is an example of a first degree equation with two variables, x and y. Here are some things that you should be familiar with. You have your one variable first degree equation, which is like 3x is equal to 6. But then you're also familiar with your two variable first degree equation, which is something that looks like y is equal to 4x plus 8, or just 2x plus 3y minus 12 equals to 0, doesn't matter. In this case, two different variables, x, y, first degree, because the highest exponent is 1. You should be extremely comfortable with these as well as solving equations that look like this. We have looked at them in the past and you have seen them in other math classes. My question for you is, what is the difference between an equation and an inequality? Now, if you can't answer this right now, keep this question in mind as we go through the next slides. Here is a review for inequalities. We already reviewed inequalities when we did the comparison method at the beginning of this term. Answer this question. Mr. Feeney wishes to build a fence around a rectangular yard whose length is 4 more than twice the width. She has a maximum of 50 meters of fencing. What is the inequality for this situation? X is width. We can use width to find the equation for length. It says a yard whose length is 4 more than twice the width. So the length is 2 times the width, so 2x, plus 4 more. The perimeter of this is therefore 2 times the width plus 2 times the length. That's the equation for perimeter. But I tell you that she has a maximum of 50 meters of fencing. So if it's the maximum length, then we have what is called an inequality. Our perimeter, found here on the left, cannot be, or in this case is less than, or equal to, because it's a maximum, of 50 meters. So this is our inequality. So now that we have the inequality, we can simplify this inequality by adding and multiplying our like terms together. And in this case, we get our x is less than or equal to 7. And in this case, our x was our width. But what exactly does that mean, x less than or equal to 7? What does that mean to the question? If the maximum amount of fencing is 50 meters, the width cannot be any bigger than 7 meters. So we know that if we want to have a maximum of 50 meters, we cannot have any width bigger than or equal to 7 meters. And since length is 2x plus 4, the length in this case cannot be bigger than 18 meters. So the maximum width and the maximum length of this yard is 7 and 18 meters. That's the only way that it cannot exceed 50 meters. Ask yourself, how many variables are in this question? Well, in this case, we only have x, and x is in the first degree. So there is one variable in this question. So we can call this a first degree, one variable inequality. And remember to keep in mind what the difference between an equation and an inequality is. So ask yourself, what is the difference between this and what we usually see in regular equations? This is very important for you not to forget a rule when solving inequalities. Whenever you multiply or divide an inequality by a negative number, you must flip the inequality sign. We've looked at this before. Please see notes on reviewing inequalities. It's with your notes on the comparison method. But on your own, solve this inequality. Negative 1 over 3x plus 7 is less than or equal to 5. The answer to this inequality, you must bring your 7 over. Again, keeping your your less than or equal to sign. You bring the 7 over, you get a negative 2. The next thing that you have to do is multiply to get rid of your fractions by a negative 3, because then we get positive 3 over 3, which is just 1. And then we multiply it on the other side as well. And because we are multiplying by a negative number, our less than or equal to sign flips and becomes greater than or equal to, so we get x is greater than or equal to 6. And if we want to write this as an interval, it's basically solutions from 6 all the way to positive infinity. Those are the solutions for this inequality. Two variable first degree inequalities is our next topic for this PowerPoint. Just to go back to the last slide, the solution x greater than or equal to 6 means that any number that is greater than or equal to 6 will be a valid number in this situation. But now that we've seen the x's, let's add our second variable y to our inequalities so that we'll have an x and a y, making it two variables. Let me reread this question. I've tweaked it a little bit. Miss Ruffini wishes to build a fence around a rectangular yard. She wants to know the possible dimensions of the field if she has a maximum of 40 meters of fencing. That is all I give you. In this case, x will be our length and y is going to be our width because we don't know anything else about them. So we're just going to call x length, y width. The perimeter can be therefore represented as 2 times the length, so 2x, plus 2 times the width, so 2y, less than or equal to 40 meters in this case, not 50, 40 meters, okay? And remember, we are using our inequality because I say maximum. Check out these keywords. So just to recap, 2x plus 2y is less than or equal to 40 meters. How do we know which values of x and which values of y are valid in this case? So if you remember in the first question, we had our x had to be less than or equal to a certain number. But how can we solve this here if we have two variables? We could pick random points and try it out. So say let's try 5, 15, so x5 and y15. Let's plug it into our equation up here, and we get 40 is less than or equal to 40. That makes sense because 40 is less than or equal to 40, so this works. So we know that 5, 15 works. X being 5, so the width is 5, and the length being 15. But that's just one point. We need to find several points. We need to know all the points. If we try another one, say 20, 10, and we plugged it in to our original equation here, or sorry, our original inequality here, we get 60 is less than or equal to 40. Does that make sense? No, because 60 is actually greater than 40. So we know that the point 20, 10 doesn't work. So our width cannot be 20 with our length as 10. Now we could do this for hours and pick a bunch of points. So there definitely has to be an easier way. Graphing the line. Only the region at the top or the bottom of the line will have the points that work for the inequality. This is where you need to whip out your graphing line skills, because you're going to be needing to graph several lines for this chapter. The region that we shade that's on top or on the bottom of the line is called the half plane. Don't worry, I will show you in a second. So for our question, we have 2x plus 2y is less than or equal to 40. Let's make this our friend. So we get y is less than or equal to negative x plus 20. Let's just plot this inequality on a Cartesian plane as an equation first. So we'll get something that looks like this. So instead of my less than or equal to, I just have my equal sign. And when I do that, I get this straight linear line. Note though that my line is solid. There are no cuts in this line. This is a solid line because I know that my inequality is a less than or equal to. If our inequality was not an equal to, the line would be dotted because it's not included. But in this case it is, so we are going to keep our straight solid line. Now that we've plotted the line, you have to shade in either the top or the bottom of this line for which values of x and y the inequality is true. So this is our inequality that we solved. We made our equation into our friend. This is what it looks like shaded. So we have a solid line that we had in the last slide, but now that we made it into inequality, we shade here. Now, the reason why we shade down here was because we know that the point 20, 10 doesn't work. So we cannot shade over here. We tested it out, it doesn't work. But we did test out a point down here and it did work. So we know to shade on the bottom. So we can say all y's less than or equal to negative x plus 20 will work. So it is less than the line. It is under the line. We shade under the line when y is less than an expression. Graphing and shading the inequality is called representing the solution set of the inequalities, and you'll see this a lot in some of your questions. So here are some step-by-step instructions when it comes to how to properly graph an inequality. When given a word problem, but sometimes you won't be given a word problem, sometimes I'll just give you the inequality. The first thing that you do if you are given a word problem is make the inequality for your solution, but sometimes it's already given to you. Once you have this inequality, you need to make it into your friend. So isolate your y. Sometimes it will be done for you already, but if it's not, isolate your y, make it your friend. Step 3, plot that inequality as an equation on a graph. So remember, we plotted our y equals to negative x plus 20. We plotted it on a graph as a line. We didn't shade anything yet. Remember that if your inequality is less than or equal to or greater than or equal to, you use a solid line. If there is no equal to after your inequality, then you just leave it into a dotted line, and we'll see that in a second. When the y is less than or equal to, we shade under. When the y is greater than or equal to, we shade over the line. And what will help you become more confident in your answer is by plugging in points on the graph into your inequality to see if you've shaded the right region. Now, I'm probably talking to you about all this and you don't understand. Don't worry, here is an example. Graphically represent the solution set for this inequality. I don't give you a word problem, I just give you the inequality. Negative x plus 4y is less than negative 4. And just to give you an idea again of what our steps are, here they are. So one was to make the inequality for a solution. It's already been done, it's given to us. Number 2, make the inequality your friend. So that's our second step, so let's do it. When we do it, we get y is less than 0.25x minus 1. So step 2 is done. Step 3, graph it as if it was an equation. Y is equal to 0.25x minus 1 looks like this. It's less than, not less than or equal to, so my line is dotted. Next, we've done 2, we did 3. Number 4, where do we shade? Now, if you remember, when our y is less than, in this case we have y is less than, we shade under the line. And that's what's going to happen here. We shade under the line. Finally, we shaded under the graph, but just in case, check your work. Let's pick some points under and over the graph to see if we shaded the right region. Let's pick a point over the line. So let's pick 2, 2. Here's our original equation. If we plug in 2, we get 2 is less than negative 0.5. That makes no sense because 2 is actually greater than negative 0.5, so definitely not over the line. We know it's under the line, but let's try a point under anyway. So let's pick 2, negative 2, and when we plug in our points, we have negative 2 is less than negative 0.5, and that is true. Negative 0.5 is actually greater than 2 if we go on our number line, so therefore the shading underline is correct. That is the end of analytical geometry. The next things that we're going to be looking at is triangles.